Hello, welcome back. It's Tuesday, Tuesday the 2nd. I did pay my bills today, close to $2,000. I still need $300. So in 2 days on Thursday, I have a bit money again on my credit card number 2. But got a long month left. So I have started to delete. I'm deleting my, for now I'm deleting my Wikipedia video because it's eating space on my external hard drive. That costs like $150. So I'm not going to empty my MasterCard credit to buy a new external hard drive. So I have been deleting like 1,000 gigabytes. I'm not deleting my old one with the first 1,000 one. So I don't like to delete everything, but I do it now. So this one, when I'm finished uploading, I will delete the video. Cause if I make, cause I have many hundred documents like this I like to read. That's many thousand gigabytes. So now it not takes space, it not use space on my external hard drive.
Ricin structure, PDB, 2AI. The AK is shown in blue and the chain in orange. Identifiers organism Ricinus communis symbol com_2159910 enters 8287993 ref seek mRNA XM_0025346031 ref seek PROT XP_0025346491 Ricin /RAS/RYCin is a lectin, a carbohydrate-binding protein, and a highly potent toxin produced in the seeds of the castor oil plant, Ricinus communis. The median lethal dose, LD50, of ricin for mice is around 22 micrograms per kilogram of body weight via intraperitoneal injection. Oral exposure to ricin is far less toxic. An estimated lethal oral dose in humans is approximately 1 mg per kilogram of body weight. 1. Ricin is a toxalbumin and was first described by Peter Hermann Stillmark, the founder of lectinology. Biochemistry. Ricin is classified as a type 2 ribosome inactivating protein, RIP. Whereas type 1 RIPs are composed of a single protein chain that possesses catalytic activity. Type 2 RIPs, also known as cholatoxins, are composed of two different protein chains that form a heterodimeric complex. Type 2 RIPs consist of an A chain that is functionally equivalent to a type 1 RIP, covalently connected by a single disulfide bond to a B chain that is catalytically inactive, but serves to mediate transport of the A protein complex from the cell surface, via vesicle carriers, to the lumen of the endoplasmic reticulum, Both type 1 and type 2 RIPs are functionally active against ribosomes in vitro, however only type 2 RIPs display cytotoxicity due to the lectin-like properties of the B chain. To display its ribosome inactivating function, the ricin disulfide bond must be reductively cleaved. 2. Biosynthesis. Ricin is synthesized in the endosperm of castor oil plant seeds. 3. The ricin precursor protein is 576 amino acid residues in length and contains a signal peptid, residues 135. The ricin A chain, 36302, a linker peptid, 303 314, and the ricin B chain, 315 576. 4. The N-terminal signal sequence delivers the preprocolli peptid to the endoplasmic reticulum, and the signal peptid is cleaved off. Within the lumen of the earth, the preprocolli peptid is glycosylated and a protein disulfide isomerase catalyzes disulfide bond formation between cysteines 294 and 318. The preprocolli peptid is further glycosylated within the Golgi apparatus and transported to protein storage bodies. The preprocolli peptid is cleaved within protein bodies by a Uniprep 02879 other data EC number 3.2.2.22 chromosomal genome 0-0.01 MB search for structure Swiss model domains interpro. Ribosome inactivating protein, ricin A chain, identifier symbol RIFM 00161 interproic 001574 pros tectic 00248 scop 21 path /scope/SUPFAM available protein structures. Endopeptidase to produce the mature ricin protein that is composed of a 267 residue A chain and a 262 residue B chain that are covalently linked by a single disulfide bond. 3. Structure. In terms of structure, ricin closely resembles a brinane, an isomer of fabrin. The quaternary structure of ricin is a globular, glycosylated heterodimer of approximately 60-65 kV. 5. Ricin toxin A chain and ricin toxin B chain are of similar molecular weights, approximately 32 kV and 34 kV, respectively. Ricin toxin A chain, RTA, is an N-glycoside hydrolase composed of 267 amino acids. 6. It has 3 structural domains with approximately 50% of the polypeptid arranged into alpha helices and beta sheets. 7. The 3 domains form a pronounced cleft that is the active site of RTA. Ricin toxin B chain, RTB, is a lectin composed of 262 amino acids that is able to bind terminal galactose residues on cell surfaces. 8. RTB forms a billable barbell-like structure lacking alpha helices or beta sheets where individual lobes contain 3 subdomains. At least one of these 3 subdomains in each homologous lobe possesses a sugar-binding pocket that gives RTB its functional character. While other plants contain the protein chains found in ricin, both protein chains must be present to produce toxic effects. For example, plants that contain only protein chain A, such as barley, are not toxic because without the link to protein chain B, protein chain A cannot enter the cell and do damage to ribosomes. 9. Entry into the cytoplasm. Ricin B chain binds complex carbohydrates on the surface of eukaryotic cells containing either terminal N-acetyl galactosamine or beta-1,4 linked galactose residues. In addition, the mannose-type glycans of ricin are able to bind to cells that express mannose receptors. 10. RTB has been shown to bind to the cell surface on the order of 106-108 ricin molecules per cell surface. 11. The profuse binding of ricin to surface membranes allows internalization with all types of membrane invaginations. The holotoxin can be taken up by clathrin-coated pits, as well as by clathrin-independent pathways including caveoli and macropinocytosis. 12. 13. Intracellular vesicles shuttle ricin todosomes that are delivered to the Golgi apparatus. The active acidification of endosomes is thought to have little effect on the FAM structures /ECOD PDB RCSB PDB. Some structure summary. Ricin type beta trefoil lectin domain, ricin B chain, Identifier symbol /8FAMP00652 FAMPLAN CL0066 Prototype 000772 SCOP21 app /scope /SUP for icon 13 CDDCD00161. A comparison of the similar structures of Agrine, red, and Ricin, blue. Functional properties of Ricin. Because Ricin is stable over a wider pH range, degradation in endosomes or lysosomes offers little or no protection against Ricin. 14. Ricin molecules are thought to follow retrograde transport via early endosomes, the trans-Golgi network, and the Golgi to enter the lumen of the endoplasmic reticulum. 15. For Ricin to function cytotoxically, RTA must be reductively cleaved from RTB to release a steric block of the RTA active site. This process is catalyzed by the protein PDI, protein disulfide isomerase, that resides in the lumen of the ER. 16. 17. Free RTA in the ER lumen then partially unfolds and partially buries into the membrane, where it is thought to mimic a misfolded membrane-associated protein. 18. Roles for the chaperones GRP94, 19, Eden, 20, and BIP, 21, have been proposed prior to dislocation of RTA from the lumen to the cytosol in a manner that uses components of the endoplasmic reticulum-associated protein degradation, pathway. ER8 normally removes misfolded proteins to the cytosol for their destruction by cytosolic proteasomes. Dislocation of RTA requires membrane integral E3 ubiquitinase complexes. 22. But RTA avoids ubiquitination that usually occurs with ERAD substrates because of its low content of lysine residues, which are fusion attachment sites for ubiquitin. 23. Thus, RTA avoids the usual fate of dislocated proteins, destruction that is mediated by targeting ubiquitinated proteins to the cytosolic proteasomes. In the mammalian cell cytosol RTA then undergoes triad by the cytosolic molecular chaperones HSC70 and HSP90 and their co-chaperones, as well as V1 subunit, RPT5, of the proteasome itself, that results in its folding to a catalytic conformation. 19. 24, which depurinatous ribosomes, thus halting protein synthesis. Ribosome inactivation. RTA has RNA N-glycosylase activity that is responsible for the cleavage of a glycosidic bond within the large RNA of the 60 subunit of eukaryotic ribosomes. 25. RTA specifically and available protein structures FAM structures /ECOD PDB RCSB PDB Some structure summary. Irreversibly hydrolyses the N-glycosidic bond of the adenine residue at position 4324, a 4324, within the 28S RNA, but lets the phosphodiester backbone of the RNA intact. 26. The Ricin targets a 4324 that is contained in a highly conserved sequence of 12 nucleotides universally found in eukaryotic ribosomes. The sequence, 5-AGAGA3, termed Sarsin-Ricin loop, is important in binding elongation factors during protein synthesis. 27. The depurination event rapidly and completely inactivates the ribosome, resulting in toxicity from inhibited protein synthesis. A single RTA molecule in the cytosol is capable of depurinating approximately 1,500 ribosomes per minute. Depurination reaction. Within the active site of RTA, there exist several invariant amino acid residues involved in the depurination of ribosomal RNA. 14. Although the exact mechanism of the event is unknown, key amino acid residues identified include tyrosine at positions 80 and 123, glutamic acid at position 177, and arginine at position 180. In particular, ARG-180 and Glu-177 have been shown to be involved in the catalytic mechanism, and not substrate binding with enzyme kinetic studies involving RTA mutants. The model proposed by Mozingo and Robertus, 7, based on X-ray structures, is as follows. Sarsin Ricin loop substrate binds RTA active site with target adenine stacking against TYR80 and TYR123. ARG-180 is positioned such that it can protonate N3 of adenine and break the bond